So as you can see, we're starting off by just looking at the core components that we spoke about earlier on. So we start off with a diagram here in the bottom left corner showing the Gpio pins and what each of them do. We don't actually need to worry about the majority of these pins. The ones that we're going to start off worrying about is knowing where we can get some power from, i.e. our 3.3 volts. And we can see that at pin number 1 we get 3.3 volts in. From here we're going to connect to the LED. Now, as we discussed earlier, we must connect to the correct side of the LED, and the side we need to connect to is the anode, which is the longer side. So we're going to make sure we connect to there next. After that, we're going to need to connect from the shorter side, which is the cathode, and we're going to connect from that cathode on with our circuit into a resistor. Now, I haven't yet explained why we need a resistor. This resistor is there just so that we can limit the amount of current that is going through the LED. If there is too much current going through the LED, then what can happen is the LED can burn out. So we've just got it there so that the LED works normally. It doesn't get too much current through it, which could blow it. So once we've got as far as the resistor to lower the current flow, we then loop back round to ground, which creates and completes our full circuit. And once we've got that far, we should find that our bulb lights.
So now we've seen how the wiring would work in concept, we're going to start wiring it practically for our Raspberry Pi. So to do this, we're first of all going to need to know which of these Gpio pins is pin 1. And the simple way to remember is that pin 1 is the one closest to the SD card. Okay. Now, we're going to need to start by connecting to that pin 1 because that is our 3.3 volt pin. So I'm going to get the female end of our jumper wire, plug that into our 3.3 volt pin, and then I've got the male point of the jumper wire that we need to put somewhere on the breadboard. To be able to know where to put this on the breadboard, we need to know a little bit about how the breadboard is connected. So you'll notice that we've got a negative rail going up along one side here. This is the case in most breadboards. And this negative rail running up the left-hand side is all connected. The holes and the connector points are in blocks of 5. So we've got 5, 10, 15, 20, 25 pins that are all connected all together. So I could connect something to one of these pins and connect anything else from it to join them all up. I've also got a plus rail here, which runs all the way up the breadboard. Now these pins are particularly useful for cases such as this, where I'm getting my 3.3 volts out of my Gpio, out of my Raspberry Pi, and I want to wire them into my breadboard. I could move that straight in and plug it into my plus side. What's the benefit of this? I can now have pins coming out of the positive side of my breadboard and off to various different points. So I can easily pull 3.3 volts from various different points on my breadboard, even though I've only got one 3.3 volt pin on my Gpio pins. We're not actually going to do this. We're actually going to be using some of these pins along here. So to explain how these pins are all connected, you'll notice closest to the camera we have pin 30A, 30B, 30C, 30D and 30E. Okay, so they're just like grid references. And each of those 5 connectors is joined. We've then got, if we carry on row 30, 30F, 30G, 30H, 30I and 30J. And those 5 pins are connected. This is the same for row 29, where 29A to E are connected and 29F to J are connected. So we've basically got a series of 5 blocks of pins all connected together. So I could easily plug in, for example, my GPIO pin to pin 30J, and from this point here I can now say, well, I can plug anything into 30F, 30G, 30H or 30I, and it will be connected to this same point. So we're going to need to do that now, and we're going to do that with an LED. Now the LED I'm using here is a green one, and you'll notice that we've got a clear difference in length of the pins, where the lower pin is slightly longer, making it the anode. That's where the 3.3 volts must come from. So I know that that longer pin is going to want to go into the breadboard at the row 30 between either F, G, H or I. The other pin, of course, I don't want to be connected to the same block, so it can't be connected to one of those other ones in that row unless we connect it on this side. So I've got a couple of options. I could connect the anode, the longer wire, into F30 and connect the shorter wire into 30E if I wanted to. That would work fine. And in fact, why don't we do that? But I could also connect my pins this way along and just plug the cathode into a different row. I'm just going to go over the join here and plug my LED just like so. So what's left to get our LED lit? Well, to start with, we're going to need another bit of hardware, which is our resistor, which we have. Now, this resistor, as discussed earlier, is a 330 ohm resistor, and I'm going to need to connect from the LED. So it's going to have to be connected to either 30A, 30B, 30C or 30D, and then onto another block. So the nice thing about resistors is it doesn't matter which way round you put them in, so don't worry too much about that. I'm just going to connect that into 30B, and I'll connect the other side into 25B. See if we can move this wire out of the way. Now, the last step to do is to complete our circuit, because we currently come out of 3.3 volts. We go into the breadboard. The breadboard is connected to the anode of the LED. It goes up the LED, hopefully lights the LED, goes back down the cathode, up this side of the resistor, down this side of the resistor, and our last step now is we need to complete our circuit. So our circuit must go back to ground. To do this, we're going to need another jumper wire. Now, you'll notice I've not been too fussy about colours at all, but of course you can think about it as you would and make your own decisions on that. So I need to connect to the side of the resistor, so I'm actually going to stick with row 26 and just go into 26. Let's go into 26E. And from there, I need to connect to the ground pin. Now, this is on the opposite side of the GPIO pins to pin 1, and it's 3 GPIO pins along. Now you can of course check this on your diagram, and you'll notice as soon as I made that connection, the LED lit. So if I pull that off again, LED is not lit. If I connect it again, we've got our lit LED. This is just our start of getting our LED lit, and of course this doesn't allow us to program. So we're going to make one small change to progress on further, to be able to allow us to modify what is happening with the LED based on some code.